Okay, so just a quick reminder, just kind of reminding everyone, we have a semester test the Tuesday after we're back from winter break. I know that's not convenient. It's just one of those things. I haven't been there, so I feel bad, and I don't want to rush into a semester test, so we're going to do it the Tuesday when we're back. That means I'm back tomorrow for sure, so we'll just continue notes like what we're doing now. Thursday through Wednesday next week, because Wednesdays I think are our last day next week. Thursday through Wednesday, we're going to start reviewing for the semester test. We're going to do a 5-day review. I do this every year. You guys will have a physical copy of your practice guide in your hand for the semester test, and then on the Monday when we're back, because I think we're back on like the 2nd or 3rd or something like that. The Monday we're back, we'll do a quick review of just like certain problems you didn't quite remember how to do, and then Tuesday we'll take the semester test. So that's to kind of give you guys a heads up. I'm going to tell every class day, but it was just, I was looking kind of the dates when I could have a semester test, because I was the last to be informed of it, and I just didn't want to put my test on like 30 other tests, because I know some kids already had semester tests yesterday, so like it's already started. So I'm going to put mine the Tuesday when we're back, so that way over break you guys can watch the videos and kind of review, because obviously we'll do 5 days of videos for those, so you can go back and watch any of those questions. Yeah, we'll get going on notes today, homework, and then as you heard earlier, if you were not in the room, we do have homework today. It'll be due on Thursday for you guys. My other classes are due tomorrow, but for you guys it will be due Thursday. It's really quick. I think it's 4 problems. That's it, 4. And it's based on what we're doing today. It's based on this hyperbola stuff, so it should be somewhat familiar. We just have to talk about a few new things. We have to talk about an ellipse, or not an ellipse, but the formula to find the hyperbola. So I'll have to do completing the square, the center, the transverse axis, the asymptotes, and the foci today. Foci is the new part. We didn't do that yesterday, so if you're not here yesterday, yeah, you missed out a little bit. We just introed the new section today. So I'll let you get your notes out. If you have a calculator, just going to make sure I have my formulas out here in front of me, so I'm not telling you something wrong. That would be terrible. So make sure you have your notes out, and we'll get started here. One formula. See. I was right. All right, are we ready to go? Does everyone have their notes?
Yes, ready? They're good.
Okay, let's get started. So we're going to take a few notes on hyperbola, as you can see from my item here. I'm just going to do a quick drawing of what hyperbolas look like. They could be vertical, it could be horizontal. I think we only did a horizontal one yesterday, so hopefully I'll show you an example of a vertical problem today. Hopefully we'll get to one. My goal is to do about 3 problems. I think that's what I want to do today. These take a while, so I'm sorry I'm not going to give you a lot of time to work in class today, but hopefully by the time we get done you'll be comfortable with this stuff. But again, let's talk about what a hyperbola looks like. So typically, on a hyperbola you have a center of a picture, kind of like your ellipse, you still have a center, but then the actual hyperbola will be, bowing outwards like this, where it looks like 2 parabolas that have, somewhat been repeated, like almost a mirror image, like a copy and a paste kind of a thing. They're on both sides, right and left, or up and down, but in this case I'm going horizontal, so it's right and left. What we need to talk about today is, okay, number 1, where's the center? That's what we have to find, so that's one of our pieces today. Can we find the center? You guys are pretty good at that from completing the square. The next thing is, can we find where the branches need to start? The coordinates for these branches, that's these parts. This is a part of the transverse axis. So transverse axis, which is where the branches are. And then the other thing we have to talk about is the other part we have to talk about is the asymptotes and the foci. The asymptotes, if you don't remember, those are the lines that cut through the center and they kind of go diagonal. It's a theoretical line. You don't need to actually have them in the drawing. I just put them in there so I can see where the branches go. Those like actual like hyperbola arcs. so they hug up right against it. So I can see kind of where the boundary is. An asymptote is, again, it's an undefined boundary where your graph can't cross. So it's a point where you're undefined at some point. So and then obviously the last thing we have to talk about is the foci, and that's the new part today. We did not talk about that yesterday. You know, the foci could be on the inside somewhere like this. This is just an example. Again, there's two foci, foci 1 and foci 2. All right, questions with kind of the parts we're going to talk about today. All right, I'm going to take silence as no. All right, so let's kind of walk through these. I think I have 3 problems picked out. I'll have to look back at how many I picked out yesterday for this. But 3 problems, kind of walking you through what you're going to have for your homework today. Your homework, there will be 4 problems. You're going to do this stuff. It's basically just give me coordinates. You're not going to have to draw anything or graph anything. You just have to tell me the coordinates for these objects. So coordinate for the center, where the branch coordinates start, where the foci dots are, and then where the asymptotes are, the formula for the asymptotes. And we'll talk about that today, so you can type that in correctly. It's really not that bad. You're going to get a lot of decimals, though. Just be aware of that. You know, the branches, the foci, you're going to get decimals. It's going to happen. So, sorry, you'll just have to deal with it as we go. But yeah, so let's jump right in, kind of walk through it. Again, if you were gone yesterday, you kind of missed out on the problem that I talked about for ellipses. You know, that follow-up problem from Friday about, you know, will a semi-truck fit into a circular or elliptical, you know, space. You can go back and watch that if you need to. It was from yesterday's video, so I made sure it was posted yesterday. But yeah, so let's jump right in. This is the first one. These are exactly what your homework are going to look like today. You're going to have 4 of these. So these are the equations for a hyperbola. How I know it's a hyperbola and not an ellipse, because they look the same. Like if you look at the formulas, the default formula, they look the same. The only thing that gives it away is this object right here. Between the x squared and y squared, there is a negative sign. That is really the only difference. So that's how I can kind of tell right away that this is a hyperbola. So we'll look at an example of how hyperbolas are created tomorrow. That'll be something we'll do in class. But yeah, this assignment we're going to get today, 4 problems just like this. They'll be due on Thursday this week. Okay. I'll let you guys get this written down. When you guys are ready, just let me know. I'll have Miss Cook tell me or something. Okay, let's jump right in. We're going to rearrange, so we're going to complete the square. So that's where we're going to move things around just like we always been doing. So you should be probably really comfortable with some of this stuff. We move the x's next to each other. We're going to move the y's next to each other. And notice I left the negative sign on the y squared, the 9y squared. It is negative, so you have to leave it there. The 54y. And then moving the 101 across, I have to make it a positive 101. All right, so we moved items around. So now what we have to do next is we have to factor those numbers out from, you know, the x's and the y's. Even the negative sign on the y, you have to factor that out. So it's a little bit different. We haven't had to do that yet. I'm going to try to color code, so I'll put these in yellow, and maybe I'll put these in a purple color back here, so you can see in color coding, so you can see where the numbers are coming from. All right, so factoring out the 4. If I factor out the 4 from the x's, I'll be left with x squared minus 4x. That's the factoring that you divided out. That's what basically factors are. They're multiples. Dividing out the negative 9 from the y's, I'm left with y squared, positive y squared, and then a negative 6y. And that's the part that always gets people, is like when you divide that out, when you divide a negative 9 from 54, you get a positive, or you get a negative 6. So the idea is that the negative sign stuck around. Alright, just let me know when you guys are good to go for the next step. Okay, let's jump right in here and we'll keep continuing. Now we're going to do half the middle squared. So these are the middle terms, right? We have to do half of it. and then we have to square that number, whatever half that is, and then take it times the number out front, and that's what we add across. There's a lot of steps there. So let's do the -4 first. So half of it's -2. We square that, -2, we get 4. You're going to take it times the number out front, and that's what I'm adding across. So I'm actually adding a 16 across. And then for the 6, same exact idea. I'm going to take half of it, which is -3, square it, which is 9. We take it times the number out front, which is -81, and that's what we're putting over here. And yes, it is a negative number, so. All right, questions with how I got that? No questions. All right, good. So let's jump right back into the next part here. We're going to add those numbers on the right side together. So 101 plus the 16, and we're going to subtract the 81. So we're adding the 16, subtracting the 81, and we're going to get a 36 on the other side. Now, for all these other parts, so for the x's, if I factor the x's apart, we're going to get 4 out front because I haven't messed with that yet. And we're going to have an x minus 2. That's always half the middle. And for the y's, I'm going to leave the -9 out front. But factoring that apart, it's a y minus 3 squared. All right. Any questions with where my numbers are coming from so far? Okay. Last step here to get my, my hyperbola here. I'm going to divide everything by a 36. I need to get a 1 on this side. So it's really like the ellipse stuff we've been doing. So I mean, it's almost the exact same steps. But yeah, so we're going to divide everything by a 36, and this is where we're going to simplify it. So what I mean by simplify, I'm going to simplify the 4 and 36 because I don't want that number on the top. Even if that turns out to be a weird decimal on the bottom, you're still going to divide that, right? And then over here, I'm going to simplify the 9 and 36. You're just going to ignore the negative sign. The negative sign is going to have to stay where it's at. That's not going to go away. So, all right. So if I do that, I'm going to go on my next slide and actually write down what we're getting here, so don't be thrown off by this. So my next slide, I'm going to write that x minus 2 squared, the minus sign, and then the y minus 3 squared. Okay, so that was the top parts that we had there. Now, when I simplify the 4 and 36 out front for my x's, what do I get on the bottom? 9. So I'm going to put that over here. Okay, good. And what about for the y's, the 9 and 36? What do I get on the bottom? 4. All right. We got a nice number. All right, so that's, if you haven't noticed, that is all the same steps. Really nothing has changed there. It's still the same rules we've been doing. It's completing the square. We've been doing that for the last 5 units now. 5 sections, not units, but 5 sections. So we did it in the last chapter, last unit. So it should be somewhat familiar with all the process we've been using. But now we have this new stuff. For now we have to go graph this thing. So let's talk about the parts. So your problems will start like we did on this last slide, right? Where they just give you kind of a scrambled equation. You have to do all your work on a separate sheet of paper. But now we're to this point. Well, now we have to read off where the center is, where the branches are going to start, where the asymptotes go, and where the foci are located. So we have a lot of stuff to kind of type in there. Let's start with the center. Okay, where's my center going to be on this one? What do you guys think? 2, 3. Thank you. Sorry. Sorry if you guys are saying it. I can't hear you. Sorry. Can't read the lips. So, all right. 2, 3. So 2 over, 3 up. All right. So there's my center. So again, if on your Google form today, I do want you to type the center. Center is this coordinate, right? So you're going to type it into the little box that you're given. All right. And again, you're not graphing. You're just, telling me where that center is. Now, for the branches on this particular type of hyperbola, it is a horizontal parabola. Now, how I know that? It's whatever variable is in the front, whatever one is positive, whatever one's in front of the negative sign. So if you have to rearrange, and I don't know if I created one that you had to rearrange the equation a little bit. But this one, the x is in front. It's in front of the negative sign. So we're going horizontal, right and left. So what you do is to find where the branches start, or the transverse axis. That's the correct term. Transverse axis. You're going to take the number on the bottom and take the square root. So if I take the square root of 9, how far right and left am I going? 3, thanks. Sorry, can't hear you. All right, so 3, good. And so that's, and how I know it's going right and left, because that's the variable that it's below. It's below the x. X's go right and left. So I'm going to the right 3 and to the left 3. And so the coordinates for the transverse axis, I'm going to be hitting, what is that? 1, 2, 3, 4, 5, 5, 3, and -1, 3. Those are the coordinates I'm hitting for where the branches are going, the transverse axis. Now that's where the branches start. So I can draw the branches off of this. I'm not going to do that yet. The reason I'm not going to draw the branches yet, like the actual curves of my hyperbola, is because I need to get the asymptotes in there. So if I don't have the asymptotes, it won't do me any good. Okay, is there any questions up to this point? Sorry, I've been kind of just going. Is there anything that you guys are confused on? Why I did a certain thing? Where I'm getting my numbers from?
No question.
Good. Sorry, I almost yawned right there. All right. Let's kind of walk through the rest of this here. So let's do the asymptotes here. Okay, the asymptotes are the undefined boundary where that you're not allowed to graph. So this gives me the border where my branches will go, where the actual hyperbola branches are drawn. So how this works, and that's what we talked about yesterday, it'll be an equation like slope-intercept form, like y equals mx, right? I don't need to worry about the plus b. I don't really care about that. But how we do this, we have to find the slope. So what you're going to type in when you type in the asymptotes, you're actually going to give me the equation. This equation, y equals mx, but you're going to have the m plugged in. So to find slope, this is what we talked about yesterday. Slope is a fraction, right? It's rise over run. So what you do to find rise over run is you take the number that's below y, and you take the square root of that number. So the square root of 4 is? Square root of 4? 2, thank you. And that number is going to go on the top. Now, how I know that? The rise number is always y's. The y-axis is always rising, so that number goes on the top. It's always the top number. The bottom number is whatever number is below x. So the square root of 9 is 3. And that's the same as the transverse axis on this particular case. But again, don't read into where the transverse axis goes. It's just the number below y, the number below x. You have to take the square root of those. So your equation, what you're going to type to me, is going to be this. Like on your Google form, you're going to type in this equation. Now, how you type a fraction into Google, you just use the little back arrow, like the little backslash key on your keyboard. So 2\3. So I want this typed in. Right? That's my equation for my asymptote. Now, how I draw that, I go from the center and I use my rise and run. I'm rising 2, running 3. Rise 2, run 3. Rise 2, run 3. Right? And I can draw that line. Again, these are just dashed lines. You could go the other direction if you wanted to. And then same thing, I can go down 2 and over 3, down 2 and over 3, because it's positive or negative. Alright, so there's my asymptotes drawn in there. It's up 2 over 3. Hopefully that makes sense. Or negative 2 over 3. Positive or negative. And now I can draw the branches. So I'm going to go back and draw those. Alright. Going back and drawing those branches in there. So now I can figure out where they're going, where they're hugging up against. They're not going to cross those. They're going to get really close to it, but they're not going to actually touch. Okay, and what is my last thing that we have to cover today? What did I talk about earlier? What is the last piece? Foci, yeah. So let's talk about foci. So the foci have a new formula here. There's a new formula for foci because we are doing a different type of drawing. So to find the foci, we have a new formula. And you'll probably recognize this formula. Where have you recognized that formula from? Anyone happen to know what that's called? It's probably the most famous theorem in mathematics. Yeah, Pythagorean Theorem. It just happens to be this because of the way that when you actually do like the full formula, like if you remember back to about 2 weeks ago or a week maybe, I showed you where they came up with the formula for the ellipse. It was like a full class. I did like 3 pages worth of notes showing you where these formulas come from, and in that formula there was this part where you had to substitute out, like it was like, I don't know, it was a squared minus c squared or something like that in the formula. We just replaced it with a b squared. Well, this one is kind of loosely based on that same thing, but it's a squared plus b squared. So it was a part in that formula you had to do. Now your a and b number are your transverse axis and the other one. A squared and b squared. That's these two numbers. Your a squared will always be the number in the front. It's whatever your transverse axis number is. So it's whatever number's out front, that's a squared. It doesn't matter which one's bigger, so don't read into that. It doesn't actually matter. They're on the same side of the equation, but the a squared is the one in the front. That's just what you're supposed to know. That's what every textbook tells you. So I'm going to put the 9 here, put the 4 here, and so that adds up to be what? 13. And the square root of 13, what is that, just above 3, almost 4. Square root of 13, 3.6, almost a 4. So 3.6, 3.60, so 3.61 if you rounded. So that means I'm going 3.6 over. So 1, 2, 3.6 over, and 1, 2, 3.6 over, and it's always along the transverse axis where I'm putting those foci. So how I find those coordinates, what you do is you add this 3.6 to your center, and you have to add it to the right variable. In my case, I'm adding it to the x's because that's the direction we went. We went right and left. So from the center to find these foci, I'm taking my center, which is 2, 3, and I'm going to be adding these two numbers to the number 2. So I'm going to be, so again, this was the center, right? This is the center. So my coordinates are going to be, if I write this down, it'll be 2 plus 3.6, 3, and it'll be 2 minus 3.6, 3. And these are the coordinates I want to see for the foci. Again, how I know that I'm adding it to the x's, because that's the direction I'm stretched. I'm stretched horizontally, right and left. If I was going up and down, you'd add your foci number, that's 3.6, to the y number instead. If I was going up and down. All right. Questions on this first one?
No.
Nothing. Okay. We're going to do probably one more. Let's do one more of these. I said you were not going to get a lot of time today. I'm sorry. So I'm going to spend most of the time trying to do some examples so you exactly know what you need to be doing here. Hopefully this doesn't seem too crazy new. I think probably the newest stuff for us is just knowing the asymptotes and how to find the foci, since the foci has a new formula. But it shouldn't seem like we're doing radically new stuff. Maybe you just got to piece together the little details, like how do you know where to add it, which direction do I go, that type of thing. You just have to figure out the little details and write those notes to yourself. But yeah, let's do a new one. Let's do one more, and that'll be it for today. So I'm only going to get through 2. All right, so here's my last one today. Last one. Okay, so we're going to rearrange this one just like we did last time. So we're going to kind of move some stuff around. So I'm going to move the x's next to each other. So 4x squared, the 8x, kind of moving those around. Moving the 9y squared, it's negative 9y squared, and the negative 18y. And moving that 6 across the equal sign. So pretty much the same, almost the same look as the last one. I think I'm going to predict that this is going to be a vertical type of hyperbola if I'm doing my math right in my head. It's kind of nice. Yeah, and I just picked these out of the book. I didn't really design them. Okay, so let's do some factoring here. I'm going to keep the same color coding we did last time, so the yellow and pink idea. All right, what do we need to factor out in front of the x's? What do you guys think? 4. Yep. 4, thank you. So we have x squared plus 2x. Okay, good. In front of the y's, what do we have to factor out? Nine. Okay. Good. Negative 9. So that's y squared plus 2y. And then we have the equals 6 on the other side. Okay, so now comes the fun detail part. Okay, so we factored out those numbers. Noticed how they changed my numbers when you divide them out. Half the middle squared, so these are my middle terms, right? So half of it's 1, we square it, still 1. We take it times the number out front, and we add that to the other side. Okay, so far so good. Half the middle squared, well that turns out to be a 1. We square it, still 1. We multiply by the number out front, and that's what we're adding to the other side. So, well, this actually turned out to be horizontal. Interesting. Alright, I was hoping that number would be a little bit bigger. Okay, so what we're going to get on the other side of the equal sign, we're going to get a 1 over here. It's kind of a unique number. I'll explain why here in a minute. Alright, and on the other side, if we factor the x's apart, that's what? X plus 1, that's half the middle. For the y's, it's y plus 1. Alright, so now what makes this problem unique is that I didn't have a number on the right side. Usually I always have a number on that right side where the 1 sits. There's always some number I have to divide by. I don't have a number there. So this is kind of a unique problem. There's the 1's already sitting over there. So, which is kind of unique, because usually we have to divide by whatever this number is, right? You divide by that, divide by that, divide by that. I don't have anything. It's kind of weird. So, this is exactly how you need to do it. You need to write it so you divide everything by 1's, because usually we always have to divide by the number what's over there. Because I'm not allowed to have the 4 on the top or the 9 on the top. You're supposed to get rid of them. So if I divide the top and bottom by 4, here's what we get. This is kind of a unique problem. We're going to get decimals here. I'm going to get, right here, I'm going to get 1/4 when I divide both top and bottom by 4, which is 0.25 on the bottom. And then over here, if I divide by 9s, divide the top by 9, divide the bottom by 9, I'm going to get like 0.1 repeating on a calculator. And on the other side, I get the 1. Because you're not allowed to have a number on the top of the fraction. So you divide by whatever that number is. So yeah, you get 0.25 and a 0.1 repeating. So it's kind of some goofy numbers on the bottom. Not clean numbers like the last problem where it was like, what, 16 and 4 or whatever it was. So, yeah.
Happens the number you divide by is a negative.
If you divide it by a negative number?
Yeah.
Yeah, so if like the top and bottom were both negative, it would turn out to be positive. So yeah.
The bottom is just negative.
What was that?
If the bottom is just negative.
Then you just leave it. Like on this one right here, right? You divide it by 9s. I just leave this negative sign out front. So, but if this number over here is negative and you're dividing everything by a negative number, what it will do is it will cancel out the negative sign. So if like this 1 over on the other side, if this number was negative and you divided by it, this number would turn out to be positive and this would turn out to be negative. And that's the type of problem I thought this was going to turn into. I thought the right side was going to end up being negative. And so when you divide, it would change the two. The y would turn positive, the x would turn negative, and you'd have to rearrange the equation. You have to move the y out front. The positive fraction has to be out front. The negative fraction has to be the second fraction. In my case, I didn't have that. This ended up being a positive 1 over here, so it ended up being really kind of goofy. That answered your question. Hopefully it did. Alright, let's go draw this thing. So x plus 1 over 1/4 minus y plus 1 over 1/9 equals 1. Okay. So I'm going to go through this pretty quick. I'm sorry. I'm just going to kind of fly through the pieces here. Hopefully you can kind of pay attention. Hopefully this makes sense. We're going to get decimals. We're going to have a lot of decimals. I kind of warned you that earlier. You're going to have decimals on these types of problems. So yeah, so the center. What is that? -1, -1. That's the numbers with your x and y. And you always pick the opposite of those numbers. So -1, -1. So here's my center, if I'm drawing that correctly. There we go. Does not want me to draw that dot. All right, there's my center. So -1, -1. Let's figure out where my branches go. What type is this? Is it horizontal or vertical? What do you guys think?
Horizontal.
Horizontal. Thanks. Sorry, I can't hear that. All right. So it's horizontal. The reason why is that this fraction ended up being the positive part. The x's ended up being positive. It was the part in the front. So it's going to be horizontal. And you have to take the square root of 1/4 or square root of 0.25. That ends up being just half when I take the square root of it, or 0.5. So I'm going 0.5 to the right, 0.5 to the left. So it's like insanely close. So the branches are going to be really, really close to this, to the center. So, again, this is the transverse axis. So if I go half to the right, half to the left, so it's -1 plus half and -1 minus half. That's how I'm getting those numbers, and I'm just adding the half to the x numbers because I'm going right and left. If I was going up and down, you add the half to the up and down number. So the y number, the -1 on the y instead. And you can write the coordinate down. You don't have to do what I did. You can put, -half and -1.5 if you want to do that. All right, you can probably hear my son crying in the background. All right. Okay, let's do the asymptotes now. So let's do the asymptotes. So for the asymptote, and this is going to be the goofy part, it's rise over run. So we have to take the square root of these numbers. Right? Because you always have to find the number below y, number below x. The square root of 1/9 is 1/3. The square root of 1/4 is 1/2. Now, we get a weird fraction, right? You are allowed to do a reciprocal. If you don't remember reciprocals in Algebra 2 class, if you have a fraction on the bottom, you are allowed to bring it to the top and flip it over and multiply it instead. That is the same as taking 1/3 divided by half. It's the same thing as multiplying by 2. So this ends up being y equals 2/3 x. So, because I'm allowed to bring that fraction up. Again, it's y numbers over the x numbers. That's how I got those. And I take the square roots. Now, most of the time, those don't work out to be fractions. They usually work out to be nice numbers. You can put the decimal in there. It's fine. But mine is going up 2 over 3. And so this is what one of my asymptotes is going to look like. And then down 2 over 3. Here's my other asymptote. So now I can draw my branches. Branches can get really close to those. That left side doesn't look too good, but you get the idea. And now we got to find the foci. Last piece here. Foci, I'm going to use the a squared plus b squared part. So 1/4 plus 1/9. So on a calculator, if I took, 1 divided by 9 and I added it to 1 divided by 4 in a calculator, I'm going to get 0.36 with a bunch of ones. And I'm going to take the square root of that. Again, that's adding 1/4 and 1/9 on a calculator, just adding those two numbers up. So if I take the square root of that number, I'm going to get 0.6. So from the center, I'm going 0.6 to the right, 0.6 to the left. So my foci are super close. They're super close to the branches. In fact, to find those foci, I'm taking my center and adding 0.6 and subtracting 0.6. So they're really close. Decimals usually make it that way. All right. That's it for today. Sorry, I kind of didn't give you any time to kind of work today. Tomorrow you'll get plenty more time. Homework's going to be on Google Classroom today, so if you want to go try some. It's due on Thursday, so I will give you time in class tomorrow, because I think we have 20-minute classes tomorrow or something like that. I think we're on that early out schedule, I'm pretty sure, tomorrow. So hopefully that made a little bit of sense to you. We'll continue this stuff tomorrow. Don't feel like we're moving on. We're not. We're going to continue some of the stuff. We'll do some more examples tomorrow. So, but yeah. So I'll see you guys tomorrow. I'll be in class. So take care, everyone. So.